Hi, this is Miss Cairo. This is math lesson 3-7. And in this lesson today, we're going to be comparing multiplication and addition with fractions. So for this lesson, what you need is your activity book, and you need to open up to page 83 is what we'll start with. And you'll also need your whiteboard and your whiteboard materials. So go ahead and gather those materials. And again, we're on page 83 in your activity book. So once you have all those materials out, go ahead and take a look at the heading on page 83 with me and go ahead and point at that red triangle and read along with me. The heading is Compare Multiplication and Addition. So we're going to be looking at fractions, and we're going to be using the same fractions and multiplying and adding them. And what we're doing is we're looking for patterns or perhaps a rule that we can follow in which, when we're looking at an addition problem or a multiplication problem that doesn't include fractions, that we can easily maybe make a prediction about what our answer will be like. Okay, so look out during this video lesson for any kind of rule that we can follow. All right, so underneath the heading, it says these fraction bars show how we add and multiply fractions. And what I want you to do is take a look at the addition and the multiplication sentences on the side, and then we'll look at the bars, the fraction bars, together once we look at them. So the first one is 2/5 plus 3/5, and they already wrote the answer is equal to 5/5. And then underneath it, they have 3/5 times 2/5, and then they have the answer is equal to 6/25. Before we look at the fraction bars again, look for what do you notice about these two problems? Yeah, so what I notice is we of course are using the same two fractions, and then I'm looking at the answers and I'm taking a notice of those as well and how they relate back to them. So let's look at the addition ones, the addition fraction bar first. So 2/5 plus 3/5, what they did is they took a fraction bar. Remember, this fraction bar is equal to 1 whole. I see that there's 5 unit fractions, and each of the unit fractions is labeled 1/5. So I have 1/5, 1/5, 1/5, 1/5, 1/5, and again, equal to 1 whole. They circled 2/5 in red, and then they circled 3/5 in blue. And how they got their answer is they basically what we could say is how many unit fractions are circled in all. So there's all 5 unit fractions are in fact circled. So each of these unit fractions have a circles around them. So that gives me our numerator 5, and our denominator is how many total pieces this fraction bar was split up into. It was split up into 5 total pieces. So in actuality, 5/5 is equal to 1 whole. Remember, anytime a numerator and denominator are the same number, that's equal to 1 whole. And that's in fact true looking at it with the fraction bar. This whole fraction bar is circled, red and blue. All right, let's take a look at the multiplication one. This one's a little more complicated. So 3/5 times 2/5 is equal to 6/25. Let's take a look what they did first. They said take 2/5 of the whole. So what they did here is they did a fraction bar. Again, this is equal to 1 whole. And they wanted to take 2/5 of it. Go ahead and circle 2/5 with me. And I can see clearly, and you might even want to actually do this. It's actually not so clear. They took the fraction bar and they split it up into 5 total pieces. And how I know that is I'm looking for those solid lines. So here's a solid line, here's a solid line, here's a solid line, and here's a solid line. So go ahead and make those solid lines maybe a little longer like I did. So I have 1, 2, 3, 4, 5 pieces. And then they said, take 2/5 of the whole. So what they did is they circled in red and 1 unit fraction at a time. So they circled 1/5 here, 1/5 here to equal 2/5. And then the next step, remember, multiplication means of. So now that we have 2/5 circled, we want to know what 3/5 of 2/5 is. So their next step is that they then took 3/5 of each fifth. So what they did is they took each unit fraction. Remember, we did this in previous lessons. They took each unit fraction, they split it up into fifths using the dotted lines. So 5 pieces here, 5 pieces here, to that goes along with the denominator. And then they went back and in blue, they circled 3 parts of each of the 1/5. So 3 out of a total of 5 parts. So 3/5 here, 3/5 here. And then to get their answer, we're asking ourselves how many unit fractions are circled twice? Circled twice with both blue and with red. So I see 1, 2, 3, 4, 5, 6 total pieces are circled twice. That gives us our numerator and our answer. And our denominator is how many total pieces did we split up our whole into? Well, remember, we split it up into fifths to represent 2/5. And then we took each of those fifths and then split them up into fifths again. So we have 5 pieces here, 5 pieces here, 5 pieces here, 5 pieces here, 5 pieces here. Remember, whatever you do to one part of your fraction bar, you have to do to the rest to create equal parts. And then 5 plus 5 plus 5 plus 5 plus 5, or 5 times 5, gives us 25. Okay, so that brings us to question number 1. Which problem above has the greater answer? So we have our 2 answers here, and you can box them with me. 3/5 times 2/5 gives us 6/25, and 2/5 plus 3/5 is equal to 5/5. Which one has the bigger answer, or the greater answer? 5/5 or 6/25? And before I even have to, we can obviously use our knowledge of fraction and number sense, but we can even look at our fraction bars to help us decide. Our addition one, look at how much is circled. We circled basically we circled the whole fraction bar. We circled one whole. And then for multiplication, what parts did we circle twice is basically what we're looking at. So if I were to put this all together, there's a lot of colors going on. Here's our answer for the addition problem in green. Here's our answer for the multiplication problem in green. I just boxed the whole thing for addition and just part of it for multiplication. Which one has the bigger amount of green boxes around them? Yeah, addition. So it was 2/5 plus 3/5 does in fact give us the greater answer. And we know that one whole is definitely larger than 6/25. And again, we're looking for patterns. And I want you to take notice, anytime we add 2 fractions together, our answer has to be bigger than each of our parts of our addition sentence. So I knew with 2/5 plus 3/5, I knew my answer had to be bigger than 2/5, and it had to be bigger than 3/5. But with a multiplication, it's a little different. Remember, we need to be basically double circling. So if I'm looking at what is 3/5 of 2/5, I know my answer is going to be less than 2/5 and less than 3/5, because remember, I'm taking just a part of whatever the fraction is that I'm starting off with. So if I'm looking at 2/5, I know that we're just going to be looking for a part of 2/5. Okay, let's see if this is true for numbers 2 and 3. So let's take a look at number 2. Circle the problem that will have the greater answer, then solve. So again, we're looking at the 2 fractions here, 2/7 plus 3/7, and then 3/7 times 2/7. Which one do you think is going to give us the bigger answer? Go ahead and circle it. Is it going to be this one or this one? Addition or multiplication? Bigger answer. Well, based on what we just learned with the previous one, we said addition for number 1. I'm thinking it is going to be addition for this one, but let's prove it. All right. So same denominator, easy peasy. Let's go back from unit 1. Adding 2 fractions together, they have to have the same denominator. Once they have the same denominator, your answer will have the same denominator. So go ahead and do a fraction bar with 7. And then the second step is just add the numerators. 2 plus 3, what's 2 plus 3? That will give you your numerator. Go ahead and write it in. Did you write 5? Great. 2 sevenths plus 3 sevenths is equal to 5 sevenths. Awesome. Now 3 sevenths times 2 sevenths, we're going to do equal sign. Let's do a fraction bar. Let's go back to our previous lessons. And let's remember, when you're multiplying two fractions, you need to simplify and then just multiply across. Can you simplify for this problem? You cannot. So since we can't simplify, we multiply across. 3 times 2 will give us our new numerator, and 7 times 7 will give us our new denominator. Go ahead and do it. And did you get 6/49? Great. Now let's compare our two answers. Which one is greater? 5 sevenths or 6/49? 5 sevenths is definitely larger than 6/49. Remember, be thinking to yourself, if I were to draw out fraction bars that are whole for this one would be 7 pieces and 5 circled. This one would be 49 pieces and 6 pieces would be double circled. So this one would definitely have more circles around it. And that goes along when we added 2 sevenths plus 3 sevenths, our answer I knew was going to be larger than 2 sevenths. I knew it was going to be larger than 3 sevenths because I would be combining those two. I knew for this one, my answer is going to be less than 3 sevenths because that would be 3 sevenths would be circled. And then I take each of those unit fractions and then split them into 7 pieces and then circle 2 out of the 7 pieces within those unit fractions. And then I'd count them all, and only 6 would have double circled. So my answer I knew was going to be less than 3 sevenths and less than 2 sevenths. All right, and let's go along with number 3. Let's see if this is true for number 3 too. It says the fractions in the problems at the right have different denominators. Underline different denominators. And then it says circle the problem that will have the greater answer, then solve. So different denominators, we're going to go back to unit 1 and remember, what do we do when we have different denominators? And then we'll solve. But before we even do that, let's take a look at them. 1/6 plus 3/4, and then 3/4 times 1/6. Same fractions, just adding or multiplying. Which one will give us our bigger answer? Adding the two fractions or multiplying the two fractions? Which one will have the bigger answer? Let's predict. Well, let's go along with this addition problem had the bigger one. This addition problem had the bigger answer. I think we're following the rule. Adding two fractions will give us a bigger answer than multiplying. So let's make that prediction. Go ahead and circle that. And let's solve. Go ahead and get your whiteboard ready because you're going to have to do much more work since we have different denominators for this. Let's set up the problem stacked. Let's stack these two fractions, 1/6 plus 3/4. Go ahead and write that on your whiteboard. Remember, different denominators, we never add denominators. We can't add 6 plus 4 and get our denominator of 10. We need a common denominator. Anytime you have two fractions and you're trying to add them, they have to have the same denominator. Common means same. So in order to do that, we stacked them. We did an equal sign. Go ahead and write out those fraction bars. I hope this is looking familiar to you guys. We need to come up with a common denominator with 6 and 4. So I'm thinking to myself, what would be my lowest common denominator for 6 and 4? What could I multiply 6 by to get something and 4 by to get something? And I'm looking for the lowest amount. I'm already thinking 24. 24 would work. Is there a smaller one? There is. What about 12? 12 is a multiple of 6 and 4. And it requires less math than if I were to choose 24. So go ahead and do times something to equal 24. And now we're going to figure out what's that missing multiple here. 6 times what gives us 12? 2. Whatever you do to your denominator, you do to your numerator. So do 2 times 2 times 2. And then skip down to here, 3/4 times what gives us something 12. 4 times what gives us 12. 3, so you do times 3. Whatever you do to your denominator, you do to your numerator. We're creating equivalent fractions here. And now we're all set up for success. Go ahead and find those, complete those 2 equivalent fractions, find those numerators. Did you get it? 2/12 and 9/12. Great. And then our last step, let's add them. Now that we have equivalent fractions with common denominators, 12 and 12, we can easily add. Denominator stays the same. And then you add your numerators. 2 plus 9 is equal to 11/12. 1/6 plus 3/4 is equal to 11/12. All right, so that's our answer for addition one. What about for the multiplication one? 3/4 times 1/6. First step, can we simplify? Is there a numerator and a denominator here that share a common factor that we can divide by? Yes, there is a pair here. Are you looking at 3 and 6 like I am? They can be both divided by 3. Go ahead and do it. Cross out, write out the answer, the division answers. 3 divided by 3 is 1. 6 divided by 3 is 2. We're all simplified, so now we just multiply across. Our answer is going to be in fraction form. 1 times 1 is equal to 1, and 4 times 2 is equal to 8. 3/4 times 1/6 is equal to 1/8. And that was in simplest form. And now we're going to go back to the problem, circle the one that has the greater answer. We predicted our addition problem would have a bigger answer. Does it? Is 11/12 bigger than 1/8? Yes, in fact it is. This is much closer to 1 whole. This is closer to 0. 11/12 is bigger. Yep, that does make sense. I predicted that 11/12 would be larger than 1/6 and larger than 3/4. It was. I predicted that my answer for 3/4 times 1/6, that my answer would be less than 3/4. It is less than 3/4 and less than 1/6. Great job. Thanks for following along. Okay, let's keep going. The next heading on page 83 is compare fraction and whole number operations. And then the directions say, tell whether the answer will be less than or greater than the red number. So box those directions with me, or we can underline them. We're going to be writing less than or greater than the red number. So we're predicting what the answer will be in relation to the red number. And I'm already previewing it. Numbers 4 through 9, they have all these letters here. Those letters will can be replaced by numbers. We call those variables. All right. And why we use variables in math is that these letters can be replaced by any number and it will follow the same rule. So then over here in the box it says, keep in mind A and B are whole numbers greater than 1. And all the fractions are less than 1. So we'll deal with the fractions in a moment. Let's kind of split this up. So I'm going to be let's just be looking at 4, 5, and 6. These all involve whole numbers, addition, subtraction, multiplication. We are predicting if our answer will be bigger or less than the variable that's in red. So what I like to do for variables is I like to replace them with easy peasy numbers. So I want you to do this with me on the side. Let's take a look at number 4, A plus B. Let's replace that with the easy peasy numbers of 2 plus 1. Go ahead and write 2 plus 1 out for me. Before we even solve, and I know you already know the answer, A is in red. I want you to circle that number 2. 2 plus 1, are we going to get an answer that's larger or smaller than 2? Yeah, we're going to get an answer that's bigger than 2. We already know the answer is equal to 3. Is 3 greater than or less than 2? It is definitely greater than 3 is bigger than 2. So we know then, following this rule, A plus B, we're always going to get an answer that's greater than, let's go ahead and write in greater. Our answer will always be greater than each of these numbers. So there was no way for me to get an answer like 1, for example, for this problem, greater. So go ahead and write that word greater next to number 4. And let's keep going with numbers 5 and 6, replacing them with the easy peasy numbers. So the number 5 is A minus B. Let's replace them with, what's 2 minus 1? We're going to be comparing our answer to 2. 2 minus 1 is equal to 1. Is 1 greater or less than 2? It is less than. So that goes along with the rule, and we know this from first grade. Our answer, if we are with our subtraction problems, the answer has to be less than what we're starting off with. So let's write less next to number 5. There's no way for us to get an answer that's greater than the number that we start off with in a subtraction problem. So for example, 2 minus 1, if you got an answer, for example, like 5, that would be a huge red flag. There's no way we can have an answer that's 5 because we only started with 2 to begin with. Let's keep going. Number 6, B times A. Let's replace B times A. Let's choose like maybe a higher number here. Let's do 2 times 3. I'm replacing B and A with 2 and 3. So 2 times 3, and 3 is in red, so I'm going to circle that. Is our answer going to be less than or more than 3? Well, 2 times 3 is equal to 6. Is 6 greater than or less than 3? It's greater. And we know this from third grade. With whole numbers, we're making extra groups. If we have a group of 3 and we're timesing it by a number, we're creating another group of 3 in this case. And then 2 groups of 3 will definitely give us more than what we started with, 6. So we know, following this rule, multiplying 2 numbers other than 1, your answer will always be greater than each of these factors. All right, this is where it gets a little more complicated, but we've been studying fractions since August now. So this should look hopefully a little familiar to you, and you should have been seeing these patterns. Take a look at number 7, AB plus CD. And again, fraction form. Let's replace these variables with easy peasy fractions. AB, let's replace it with 1/3. And do this on the side with me. 1/3 plus 2/3. Let's replace CD with 2/3. And then we're asking ourselves, is our answer going to be less than or greater than 1/3? 1/3 plus 2/3, let's just go ahead and solve, is equal to 3/3 or 1/2. Is that greater or less than 1/3? It's greater. And that goes along with what we were doing up here with problems 1 through 3. Anytime we add 2 fractions, our answer has to be greater than each of those fractions that we have in our addition sentence. Greater. Okay, and then number 8, AB minus CD. So a fraction minus a fraction, are we going to get an answer that's greater than or less than the fraction that we start off with? So let's do 2/3 minus 1/3. Is our answer going to be greater than or less than 2/3? So for example, if I said I had 2/3, 2/3 a cup of sugar, and I spilt 1/3 on the floor, how much do I have left in my container? Can I have more than 2/3? I can't. I only have 2/3 to start off with. So if I'm taking away, our answer has to be less than 2/3. And for example, this one, 2/3 minus 1/3 is equal to 1/3. That is in fact smaller than the fraction that we started off with. So for number 8, it is less than, our answer is less than the fraction that we start with. You can never get an answer that's greater than the fraction that you have at the beginning of your subtraction sentence. And then number 9, CD times AB. So multiplying two fractions, are we going to get an answer that's greater than or less than each of the factors? This is where it gets a little tricky. In fifth grade, we need to understand that when we multiply two fractions, our answer is actually going to be blank than each of the factors. Well, let's replace it with 2/3 times 1/3. 2/3 times 1/3, let's go ahead and solve. We can't simplify, so just multiply across. And what do you get as your answer? 2/9. I want you to visualize 2/9 in your head. I want you to picture a fraction bar. I can actually draw it out really quickly. If I were to split it up into 9 pieces and shade 2 in, it would be about that. Maybe even less. Is 2/9 greater than or less than, for example, 2/3? It's less than 2/3. Is it greater than or less than 1/3? It's less than 1/3. Our answers for multiplying two fractions by each other will always be less than the two factors. So for number 9, less. 2/9 is less than 1/3. It's less than 2/3. And how I know, I can also create equivalent fractions to compare as well. So take a look at numbers 4 through 9. Look at those patterns. I see for addition for whole numbers and for fractions, we got greater, greater. Subtraction problems involving whole numbers and fractions, less than, less than. And here's the difference. When you multiply a whole number times a whole number, you will get an answer that's greater than both of these numbers. But when you're multiplying a fraction times a fraction, your answer is going to be less than each of your factors. All right, so that's the end of the lesson. I'm going to preview problem number 10 with you, and you're going to do some thinking about it, and then you'll come back to it. How is multiplying fractions different than multiplying whole numbers? Oh my goodness, I already said it. So we're boxing in, we're really zooming in on 6 and 9 here. How is multiplying fractions different than multiplying whole numbers? You should be seeing it, and hopefully you're following along really closely. All right, thanks for watching.